Hi, I'm John. You might have seen these animations that we posted on Twitter a few days ago showing CT scans of Doritos, Cheetos, and Ruffles. We took the scans and we rendered them in Blender, and then we 3D printed them and decorated them by hand. So today I'm going to show you how I did this in Blender. So the first thing to understand about CT data is that it's volumetric. This isn't a mesh like you might be used to working with in Blender or with a 3D printer. This is a set of 3D pixels or voxels, and each voxel has a value that denotes the density of the area that it covers. So this is our bag of Doritos that we captured in our Neptune CT scanner. You can see that we can see the bag as well as the chips inside it. And we're able to use this histogram here to exclude less dense areas, like the bag, and isolate just the denser areas, like the chips and the crumbs that are at the bottom of the bag. So to get from this to a mesh, we can use our Neptune analysis software to create a mesh, and we see here a slice of our bag. So we're going to tell the software where to apply the mesh. This is kind of like, we're kind of like surrounding the chips with a balloon and then sucking the air out in order to figure out where the mesh surface will be. And we can set the mesh surface at a very low density like this, in which case we get a lot of the bag as well as even bits of the air inside the bag, or we can set the density at a very high level like this, in which case we're only getting the crispiest, burnt corners of the chips. By going right here in the middle, around 0.5, I think we'll get the result we want. And we're going to hit Export Mesh, and in a few minutes, our mesh will be ready in Voyager. So then after a few minutes, our mesh is ready. And this is a mesh that is drawn around our volumetric data at the threshold that we specified a minute ago. So this is an STL that we can download and import into Blender. We did the same things with our CT scans of Ruffles potato chips and Cheetos here, and exported meshes of all of these snack foods as they are in the bottoms of their bags without seeing their bags. You can find the same files that we've already exported for you here on our page. If you go to lumafield.com and find the blog post that we wrote about Doritos, Ruffles, and Cheetos, scroll down and you'll find a link here to a Google Drive folder where you can just download these yourselves, as well as downloading the Blender file that we're using in this tutorial. All right, so here's Blender. I've gone ahead and opened the file that's provided in the Google Drive folder, and you can see that we have these 3 clumps of chips. If we go over here, we can give them a light render or shade them completely by going over to the right. It'll take a minute to compose the first time, but here they are. And so I'll walk through what we're seeing here. Each of these started out as an STL file exported from LumaField Voyager, derived from the CT scan. We've got the Cheetos, the Ruffles, and the Doritos, each as a separate object in the Blender environment. We created a texture for each of these that takes into account the unique characteristics of these snack foods. In particular, each of these is really speckled with several different colors. You have the range from sort of orange to off yellow in the Cheetos, you've got the yellow and white in the Ruffles, and you've got sort of burnt yellow with black specks in the Doritos. Let's take a look at what these look like. In the Cheetos, for instance, we can go down here to our shaders and see that we're using a noise texture here to begin to capture kind of the blotchiness of the Cheetos. It's going through a color ramp where it's driving this gradient between orange and yellow, and then that's coming into a principled BDSF shader. At the same time, we're going from the color ramp into the displacement characteristic of the material output. So that creates a little bit of a 3D map on the surface to give it an extra aspect of kind of bumpiness that you would see in the real chips. We see something similar here in the Ruffles, and we're using a noise texture again to go from kind of a dark yellow to a mid-yellow. We're not using the same displacement characteristics that we are in the Cheetos. The Ruffles are a little bit smoother, and we've captured a lot of the texture already in the STL, so we don't need to go a lot further there. And then in the Doritos, this is, again, using a noise texture with a color ramp from black up to sort of burned orange. And we're blending that as well with another texture using the Musgrave texture here in order to make it a little bit more realistic, in order to generate the black specks that appear, that are sort of the seasoning on the surface of the chip. These get combined into a principled BDSF shader, and we're using the displacement again here. So from there, you can use some pretty standard Blender techniques to do whatever you want. You can go ahead and render it as an image. Let's see how this looks. Beautiful. And of course, you can also animate it and imagine what it would look like if you saw these chips twirling. This is the animation that we shared online. So for this, we bring up our animator timeline. Where is it? There we go. And what we have each of these do is just rotate. So we keyframe each one's Z rotation up here at the beginning and the end of the animation. And we use Blender's built-in easing to make these move very, very pleasingly. So that's a look at how you can go from a CT scan of something like a bag of Doritos or something much, much more serious like a part that's failed or a priceless artifact and bring it into an environment like Blender so that you can render it.